Good evening, everyone. My name is Dominus Orbis, and today I will be doing Packet Tracer 7.2.2.3, configuring generic routing encapsulation. So this is going to be RFC 2784, and you can navigate to this link here to read that if you're interested. It is a stateless protocol, and it treats each request as an independent transaction that is unrelated to any previous request, so that the communication consists of independent pairs of request and response. So pretty much you don't need a server to retain the session. Information about the status, about the communication partners for the duration of multiple requests. A protocol that does require an internal state on the server is known as a stateful. So it's like the difference between TCP and UDP. No flow control. These are kind of the downsides of this. It was initially developed by Cisco. So it was proprietary. I'm not sure if it's open or not yet. It has 24 bytes of additional overhead in the headers, and we're going to talk about that. It's non-secure. All the information is sent in plain text, and it's site-to-site VPN tunneling protocol. Pretty much, the GRE tunnel is the carrier protocol, and the IP network is the transport protocol. One of the benefits is that GRE can actually encapsulate pretty much any layer 3 packet inside this packet header right here. Here's those 24 bytes I was talking about. And it has flags which identify the presence of optional header fields and the type of the payload. So ether type is hexadecimal 80800, and then it's for like IPv4, for example. Point is, it's just a encapsulation protocol which will allow you to send IPv4, IPv6, AppleTalk, pretty much any layer 3 protocol packets in a tunnel encapsulated in the GRE protocol, and then the other side will be able to decapsulate those packets and read them. So the scenario is you are a network administrator for a company which wants to set up a GRE tunnel to a remote office. Both networks are locally configured and you only need the tunnel configured. So I'm going to be going out to the internet from RA to RB. So I need to set up a tunnel. And the ping failed. I cannot reach the interface of the tunnel. And look at there. So I can communicate with RB on these serial interfaces right here. I just got a ping. Because they're probably doing no protocols. Oh, that's why. It has a default route. It's just allowing all traffic. Just for simulation. Yeah. Okay. No problem. That's not realistic though. You would never want to have a static default route that allows all traffic. Never. Now we need to do the same. And ping our router A from router B. And success again. Okay, good. So everything's up and running. They can communicate. Now let's create a tunnel. Alright, now we're going to actually ping from host A to host B. And of course, we're not going to get a reply. It's almost unreachable. Because we haven't set up that tunnel yet. That ping will also time out. Okay? And all four were lost. Alright, let's move on. Now we're going to go ahead and configure the tunnel 0 on the interface of RA. Enter the configuration. Alright. It even tells you right here, tunnel interface. There we go. Create the tunnel interface. We get the log message, link 5, link, levels 5, interface, tunnel 0, change setup. Good. Let's set an IP. Done. Okay. Now the tunnel source commands. Source of tunnel packets. RA000. Let's look at the topology here. Here's the source. Here's the destination. Alright, good. Alright, now we need to set the destination, and that's going to be the actual public IP address of the destination physical interface. Okay? Now the tunnel goes up. And now we're going to set the mode, which is already defaulted in GRE with a Cisco router, to GRE IP, but that's what Packet Tracer wants us to do. mode. Let's look at the options. We have IPv6, IP. Realistically, we could do pretty much any layer 3 protocol, but this is the limitation of Packet Tracer. So, tunnel mode, GRE, IP over IP. Sure, why not? It's already active, but best practice, do a no shut. Always. What's 1500 minus 24? Remember, the additional packet header has 24 bytes of overhead. 1500 minus 24 is 1476. The router automatically adjusted the maximum transmission unit, that is, or like the size of the packet, to compensate for that overhead. It's pretty cool. We could also do a show IP interface tunnel 0. We can do a show IP interface brief. Looking good. Alright, next we got to do the same thing on RB. So let us continue. RB. Right on. Alright, now we're going to create the tunnel interface. That's step 1. Then step 2, go ahead and give that bad boy an IP, which we need to refer to the topology, the assignment, of course, they made everything easy. Remember, the destination is always the physical interface IP, the public address of the end link. So, this guy right here. Look at that. Brought it up. Just checking to see what the default mode for GRE was. But I don't remember the command. I think that's in the next packet tracer. Oh, here it is. Transport GRE IP. Yeah, so it's the default already. But to get your points, you have to configure it. That's what we're all doing, right? Getting our points. There we go. And remember, no shut. And now let's set up a route for that tunnel. So we don't have a routing protocol, so we need to set a static one. So we're going to send all packets that are destined to the 192.168.1.0 router A's LAN to the next hop, which is the tunnel address, the logical address, not the physical one right here on the serial. That's really important to differentiate. All right, and then there we go. Do a do show run. Confirm the route is there. There it is. Do right. Do show IP route. There's those routes that I just created right there. That one. This one, the packet tracer I already had configured. Let's go to RA. Set up a default route for the other end of that tunnel. My local LAN, or no, I'm sorry, the remote LAN, router B's LAN. This is going to route all that traffic to the tunnel end interface. There we go. Okay, let's do a little troubleshooting here. Testing, I should say. Gonna ping PCB again. And now I get through. Let's do a trace route. So from PCA here, traveling to PCB. Let's look at the path. Alright, it goes through the gigabit interface G00 on router A. And then it goes to the tunnel endpoint on router B, right here. So the internet and these physical interfaces don't even see the packet. That's pretty cool. And then it ends up on PCB. So overall, I really like this packet tracer. And once again, my name is Dominus Orbis, and I hope this video has been informative, and I want to thank you for viewing. Have a good evening.